All right, guys. Today I want to look at the chain rule. All right, so chain rule. How do we use the chain rule properly? And I can also give you another shortcut. All right, if you're new on this page, let me introduce you to SIGMath, where we put a stop to math anxiety. Number one, make sure that you follow if you haven't done so. Number two, make sure that you tap on the screen. Yep, tapping on the screen is free. Tapping on the screen is free. And the more likes we get, then the bigger the community will get. And finally, number three, be active. Be active in the chat, participate. Shout out to Camille's Mobile Boutique. She's been a recurring viewer. Shout out to her. We really appreciate her contribution and her supporting the community, basically. So are you guys ready to look at the first question? The best way to study math, in my opinion, follow SIGMath. Be part of the SIGMath community. Be part of the SIGMath community. That's the best way. Best way. Like we usually say, think different, right? And solve together. That's what we do here during these lives. Everybody has his own approach to math questions, but we solve together. Does that make sense? Think differently, solve together. All right, let's look at the first question, guys, shall we? Let me give a couple seconds here. Really give us a couple seconds. Grab your seats. Grab your seats. We will make sure that the chain rule is no longer a myth. That the chain rule is no longer a myth. Anybody taking Calc 1 right now? Anybody taking Calc 1 right now? It is good. All right. So when it comes to using the chain rule, I will show you one way. Okay? The chain rule. So the chain rule goes as this. When do you use the chain rule? You use the chain rule when you have a composite function. Composite function. Okay? So what does that mean by composite function? If we go back to algebra, when you have f of g of x, or it can also be written as f of g of x. That's the time you use the chain rule. Okay? Grand Rising, Slim JI 22, returning. How you doing this morning? Burke, returning as well. How you doing this morning? So this is when we'll be using the chain rule, when you have composite function. All right, so I want to define this, okay? So I'm going to let f being the outside function. Excuse me. So f is going to be the outside. I'm doing great. We're back at it again. Like I usually tell you guys, we're going to put an end to math anxiety. We're going to put an end to math anxiety. Confidence, that's what we're here for. No more math anxiety. No more I have PTSD. When I was in elementary school, I was scared of math. I hate math, this and that. I used to have nightmares about equations. It's gone. Okay? So G is going to be the inside function. Okay? So how does the chain rule go? So let me give you the chain rule. So the chain rule goes as when you have f of g of x, you're trying to find the derivative. Yes, I will do that. Don't worry. I just want to put the thing out there, and then we're going to use it. Don't worry, Burke. I got you. So that would be derivative of the outside times the derivative of the inside. I mean, what am I telling you? I think I'm not fully awake now. So derivative of the out, I mean, what am I telling you guys? Derivative of the inside times the derivative of the outside, and you replace x by the inside. Okay. So maybe those wording don't make sense, right? Let's look at it now. Shall we? Let's look at it. So here the inside, what is the inside function here, guys? What's the inside function? So the inside function is whatever we have inside the parentheses. That's my inside function. Okay? So here, so then that means here g of x is your inside. So g of x here is going to be 5x minus 8. That's the inside function. So the derivative of 5x minus 8. What's the derivative of 5x minus 8? Chat. What's the derivative of 5x minus 8? Five. Perfect, Kenneth. Derivative of 5x, that's 5. Derivative of negative 8, that's 0. So I have the inside. Now the outside. So the outside function is going to be once we remove the inside function. Let's say I remove this now. What is the outside function going to be? Because I took the inside function out. So the outside function will be parentheses to the power of 4. You guys agree with me? Parentheses to the power of 4. You guys agree with me so far? Parentheses to the power of 4. So now since this is empty, we're just going to put an x there. Remove the inside, put the parentheses, keep everything else, and then put an x in there since it's empty. We don't want it to be empty. Okay? We don't want it to be empty. So now f prime here is going to be, we know the derivative of x to the power of 4 using the power rule. The power rule is going to be 4x cubed. Are we all on the same page, guys? Are we all on the same page? Let's get the likes up. 4x cubed, perfect. So now we use the chain rule. Let me write the full chain rule here without using the words. That would be f prime times, g prime, my bad, times f prime of g of x. So now here, y prime, or dy over dx. Let's write dy over dx here. We're looking for the derivative. Right? Let me make sure we all see this. So here the derivative is going to be the derivative of the inside, f prime. What is g prime? G prime is 5 times f prime. F prime is 4x cubed. So f prime is 4x cubed, right? 4x cubed. But it's supposed to be f prime of g of x. So instead of having x, I'm going to have g of x. So instead of having x, so this is what I'm going to do. All right. Be patient with me. I'm going to go step by step. So we all understand this, okay? We all in this together. So 4 times x to the power of 3, right? This is f prime. But since we're doing f prime of g of x composite function, I will replace x by g of x. What's g of x? G of x is 5x minus 8. Boom. Here's my answer. Are we all on the same page, guys? Antiderivative, next time. Primitive, next time. Are we all on the same page, guys? Are we all on the same page? So now we do 5 times 4, that's 20. So that'll be 20. 5x minus 8 to the power of 3. Okay? You didn't really understand? Okay. We're going to look at one. Don't worry. I'm here. I'm glad you're raising your concern. I do not know this. So this is calc. All right. Let's look at another one. Okay. Let's try to understand this. Okay. All right. So here I have y is equal to 4x minus 1 cubed. Okay. And okay. So here we trying to find the derivative of y. Okay, we want to find the derivative of y. Okay, so what's the derivative of y here? We're using the chain rule. Or you can use this rule, by the way. Whenever you have f of x to the power of n, you're trying to find the derivative. That would be n times f prime times f to the power of n minus 1. Use this instead of the chain rule. Okay? Let's use this instead of the chain rule, shall we? Let's get the likes up, guys. Let's get the likes up. So let's use this instead of the chain rule. Okay? So now what does this become then? So here f of x is going to be this whole thing. So now dy over dx would be equal to n, that's my exponent, 3, times f prime, f is for x, so f prime has to be the derivative of 4x minus 1. What's the derivative of 4x minus 1? Derivative of 4x minus 1, that would be 4 times f of x, that's 4x minus 1 to the power of 3 minus 1. Do you guys agree with me on this? Do you guys agree with me on this so far? Are we all on the same page, guys? Are we all on the same page? This is one thing that most students struggle with. I'm gonna be honest with you, straight up. Chain rule is one of the things that students struggle with when it comes to calc. The product rule, easy. Quotient rule, easy. Power rule, easy. But this is where most of them they struggle with. So 3 times 4, that's 12, times 4x minus 1 to the power of 2. Boom. Do you guys find this much easier than the chain rule? I think the chain rule is made hard because students tend to, like, it might not be obvious for you to figure out what's the inside function and what you're going to use for the outside function. In other terms, what would you choose for f of x and what would you choose for g of x? I thought you dropped the 3 to the front. Yes, I did. Here's the 3. I indeed dropped the 3 to the front. Oh, you thought you dropped the 3 to the front, leave the inside alone. Okay. So I think this is going to be much easy. This is basically based off the chain rule. So take this formula then. Take this formula. Take this. So instead of, if you think that it's kind of hard for you to find the inside function, the outside function, then use that. That's going to be much easier. Matter of fact, the next question, I will solve it using both techniques. And let's see, what do we get? Okay, so here I have y is equal to 5 times 2x, 5 times 2 minus x cubed to the power of 4. Okay, let's use what we said. So we said that f to the power of n prime would be n times f prime times f to the power of n minus 1. Are we all on the same page, guys? Let's get the likes up. Okay, f prime, it's not f to the power 1, this is f prime, by the way, f prime. Okay, so what I will do is, we'll ignore the 5. Let's ignore the 5, okay? So now I'm focused on this. This is going to be f to the power of n. This is going to be f to the power of n. Okay, so f to the power of n. Now all we have to do is use the formula. So n is 4 here, so that will be 5 times 4 times f prime. Basically, we're looking for the derivative of this thing right here. The derivative of 2 minus x cubed, derivative of 2, that's 0, derivative of negative x cubed, that will be negative 3x squared, and then times f of n minus 1, f of x, that's 2 minus x cubed to the power of 4 minus 1. Are we all on the same page, guys? Are we all on the same page? Any question? Are we all on the same page? It's going to be dy over dx. Are we all on the same page, guys? So if you think that it's kind of hard for you to identify the inside function and the outside function when it comes to the chain rule, just use this formula, because anyway, this formula is based on the chain rule. Are we all on the same page, guys? All right, so now it's just a matter of combining the like terms. 5 times 4, that's 20. 20 times negative 3, that's negative 60. X squared times 2 minus x cubed to the power of 4 minus 1, that's 3. Boom. Does that make sense, guys? Does this make sense? Let's get the likes up. Let's get it up. Derivative made easy. So if you're struggling with the chain rule, this is another alternative. If you are struggling with the chain rule, this is another alternative. Okay? All right, guys, let's move on to the next one. Like I said, when it comes to the chain rule, identifying... why don't you guys solve this? I'm going to let you guys solve this and you put your answer in the chat. What do you think g prime would be equal to here? Put your answer in the chat. Put your answer in the chat. What do you think g prime would be here? Put your answer in the chat. What would be the answer to this? Solving for g prime. Anybody in the chat? Anybody figured it out? Okay, I see negative 108 times 4 minus 9x to the power of 3. I see 12 times 4 minus 9x times 9 to the power of 3. Okay, let's do it together then. This is calc. All right, so guys, remember what I said. Okay, so I'm going to use the formula. So what are we going to do, guys? So g prime here, my g prime here would be, we isolate the variable, the constant. It's going to be right here. And then all we have to do is find the derivative of this. Okay, think of it as similar to the power rule, okay? So we're going to bring down the 4. So that'll be times 4 times, now we find the derivative of this thing. So the derivative of this thing, 4 minus 9x, the derivative of 4, that's 0. The derivative of negative 9x, that will be 9 times negative 9. I put parentheses so then I'm not confused whether I'm subtracting or multiplying. And then times the function itself, 4 minus 9x to the power of 4 minus 1. Are we all on the same page, guys? Are we all on the same page? Are we all on the same page? Are we all on the same page? Okay, so now combine the like terms. 3 times 4 times 9. 3 times 4, that's 12. 12 times 9. 12 times negative 9, that's actually negative 108. Multiplication facts times 4 minus 9x to the power of 4 minus 1, that's 3. Boom, here's my answer. Okay, how are we doing in the chat? How are we doing in the chat? Is it getting easier and easier? Is this getting easier and easier? Chat, you guys let me know. Is this getting easier and easier? That was number 4. All right, now we move to number 5. Move to number 5 now. All right, so here I have f of t is equal to square root of 5 minus t. Okay. So what I can actually do is rewrite f of t as a power. So f of t can be written as 5 minus t to the power of 1/2. Do you guys agree with me? Do you guys agree with me so far? Do you guys agree with me so far? Okay, so now all I have to do is use the formula. Let me remind you of the formula. F to the power of n prime is equal to n times f prime times f to the power of n minus 1. Because that's square root. 1/2 is because that's square root. So you, for example, let me give you an example. Let's say you want to impress someone, right? And instead of asking them what's the square root of 4, you can be like, what's 4 to the power of 1/2? So square root can be written as a power of half, 1/2. Okay, so then once I apply this, so that means that f prime here now becomes, drop down the exponent, times the derivative of 5 minus t. Derivative of 5 minus t, that would be -1. And then the function itself again, to the power of 1/2 minus 1. Are we all on the same page, guys? Are we all on the same page? Okay? So the rest now is history. 1/2 times -1, that would be -1/2 times 5 minus t. 1/2 minus 1, that's going to be -1/2. Boom, here's my answer. Here is my answer. Any question? Any question in the chat? Anybody has a question in the chat? Anybody has a question in the chat? Anybody? So we're all good, right? We understand how to do it now. All right, let's do one more, and then I'm going to evaluate with you guys. I'm going to check back with you guys. Would you simplify to fraction form? Yeah, it's possible. Oliver, that's a good question. You can leave it as this. Or if you want, you can write it as -1 over 2 times 5 minus t to the power of 1/2. Or you can even write it as -1 over 2 times square root of 5 minus t. That's my answer. So these are different versions of the answer, but they're all the same. Okay, so now maybe it depends on if you have, you know how you have different parts of the question. Maybe if later on they would like you to find what is f of 2, for example, then maybe this is going to be easier for you to find f prime of 2. Does that make sense? So it depends on what's going to come next. If they're only asking for the derivative, then either one is going to work. But if there is a leading question after that, for example, finding f prime of 2, then maybe this is going to be easier for you to see what f prime of 2 equals to, compared to you trying to do it here. If that kind of makes sense. Any other question in the chat? Any other question in the chat? All right. So we move on then, guys. So here we have number 6. Number 6, we have y is equal to the cubic root of 6x squared plus 1. cubic root of 6x squared plus 1. All right. So same thing. So what do you guys think the first step is going to be here? What will be the first step to make it easier on ourselves? First step. First thing to do. What will be the first step? Chat. You guys are going to be active, man. I hope you're not using your phone meanwhile you're watching the live. Going to be 100% focused on the live. Rewrite it. Shout out to Gio. Shout out to Gio. Gio has been a recurring viewer. Shout out. Okay, all right, so we're going to rewrite it. So I'm thinking that, I think I know what Gio means. It means, let's write it as he or her, or she, I'm not sure. Just clarify in the chat for me. So that'll be that'll be 6x squared plus 1 to the power of 1/3. Are we all on the same page, guys? Are we all on the same page, guys? Are we all on the same page? Okay. So now we use what we said. F of n prime will be n times f prime times f to the power of n minus 1. So now this becomes, so dy over dx now becomes n, I drop down the exponent, 1/3, times the derivative of 6x squared plus 1. What's the derivative of 6x squared plus 1? What's the derivative of 6x squared plus 1? Anybody in the chat? Derivative of 6x squared plus 1. What is that going to be? No, it's not going to be the product rule. 12x, so that times 12x times the function itself, 6x squared plus 1 to the power of 1/3 minus 1. We good? All right, so then the rest now is easy. 1/3 of 12x, that's 1/3 times 12. That's going to be 4x times 6x squared plus 1 to the power of 1/3 minus 1. That would be negative 2/3. Or if you want, we can go even further. Write as 4x over 6x squared plus 1 to the power of 2/3 using the properties of exponents. And even further, if you want, we can write it as 4x over cubic root of 6x squared plus 1 to the power of 2. Boom, here's your answer. So I gave you guys different variations, different forms of the answer. Are we all on the same page, guys? So if someone writes this, they're right. If someone decides to have this, they're also right. If someone decides to have this as well, they're also right. So those three are right. Are we all on the same page, guys? Gio, I think it's a great tool to be able to simplify. I think it's gonna be much easier in some cases, right? Like I said, if for example there is a leading question, like find for example f prime of 6, so that would be great. But technically, if you look at it, I didn't simplify. I just rewrote it. Nothing was simplified from here. So from here to here, what did we use? We used the properties of exponent. And you guys know the properties of exponent. A to the power of negative b is 1 over a to the power of b. You guys knew that. So that's the technique that I used to move from here to rewrite this as this. Nothing was simplified. And the same thing here. So a to the power of b over c is the same as c root of a to the power of b. Those are the two that I used to rewrite these. But nothing was simplified, Gio. The only place where we simplified was here. 1/3 times 12x. Does that make sense? So now it depends. Maybe you don't have time. Anyway, I just want to make sure that, we all see that it's the same thing. Yes, you can also use the chain rule. So here the inside function is 6x squared plus 1, and the outside function is going to be x to the power of 1/3. That's possible as well. Are we all on the same page, guys? Let's move on. Let's go number 7 now. Shall we? Let's go number 7. So here I have to find the derivative of square root of x squared plus minus 4x plus 2. All right. What will be the first step? So let me do it. Let me use both of them, okay? Let me use the case where we're using f to the power of n. Okay? Then here I will use chain rule. All right, guys, let's get the likes up. And here I would have f to the power of n prime, that's n times f prime times f to the power of n minus 1. Okay? So which means that now the first thing that I'm going to have to do here is rewrite this whole thing. So that would be, so that means, let me write first of all, f of x will be x squared minus 4x plus 2 to the power of 1/2. And then now that I'm looking for f prime of x, drop down the exponent, find the derivative of x squared minus 4x plus 2. That would be derivative of x squared, that's 2x. Derivative of negative 4x, that's negative 4. Okay? And then times the function itself, x squared minus 4x plus 2 to the power of, I'm going to have to move the line a little bit, slightly, to the power of 1/2 minus 1, that's negative 1/2. Right? That's one approach. Or if you want to use the chain rule, also, we find the inside function. The inside function is this. So you mean g of x here is x squared minus 4x plus 2. And then my f of x here is going to be square root of x. So which means that g prime now here is going to be 2x minus 4. And then f prime is going to be derivative of square root of x. That's the same as 1 over 2 square root of x. And all I have to do is use the chain rule, finish it up. So that would be g prime. G prime here is 2x minus 4 times f prime. F prime, this is what we have for f. This is what we have for f prime, 1 over 2 square root of x. And instead of having x, we replace by f of x. By g of x. G of x is x squared minus 4x plus 2. So guys, looking at this, seems like we got two different answers, right? But we have the same answer. Do you now see? Because someone may think that we got two different answers, but no, we don't. Because I can rewrite this to get this. It's to the power of negative 1/2. So this can be written as 2x minus 4 over 2 times x squared minus 4x plus 2 to the power of 1/2. And to the power of 1/2, that would be square root. Are we all on the same page, guys? Are we all on the same page? Let's get it up. Let's get it up, guys. All right. So, guys, I need your opinion on this. How many of you guys would be in favor of being able to access all the lives that we've done so far, from the beginning to the end? I'm not talking about short clips. I'm talking about the full video of the lives that we've been doing. How many of you guys would be in favor of that? Because I know sometimes I go live and with the time difference, you're not able to catch my live. So how many of you guys would be in favor of that? Were you able to access all the videos, all the lives that we've done so far? can go back, you can replay, you can take notes. How many of you guys will be in favor of that? How many of you guys will be in favor of that? Put in the chat. Being able to access all the lives. You missed it, no worries. You can still, you have access, you go, you watch, you take your notes. How many of you guys? How many? So far I see 2. How many of you guys will be in favor of that? How many of you guys will be in favor of that? And on top of that too, I can also have some of the worksheets that we've been using, the work that we did, so you can back it up too as a PDF form, and you can keep it. I need you guys to be, let me know. So far I see 3. Everybody else, I need you guys to let me know how many of you guys would be, would you be interested of having access, right? Unlimited access to the videos, the TikTok lives that we've been doing from the beginning, the entire, I'm not talking about short clips, the entire thing from beginning to the end. You can replay, you can, you can study off of it, unlimited access. So even if you end up missing the live or you missed part of the live, then you can have access to that. Who would be interested? So far, I think I saw 4 people interested. Who would be interested? And you would have, like I said, all the lives, whether it was on fractions, it was on decimals, derivatives, integrals, limits, you name it. How many would be in favor? I need your feedback, guys. I need your feedback. How many would be in favor? Guys, let's look at number 8 now. Aren't you supposed to add dy over dx? No, we're not doing integral. We're doing derivatives. We're doing derivatives. We're not doing integrals here. We're doing derivatives. So we don't know dy over dx. They gave us f of x. So if they give us f of x, then it has to be f prime of x. So, but if they gave us y here, then yeah, this would be dy over dx. This would be dy over dx. Right? We're differentiating y with respect to x. Okay? All right. So what is that going to be here then? Well, you guys know it. Right? The first thing is we're going to keep the constant out of the way. And now we're focused on this. Right? Like I said, we have 2 ways of looking at that. You can actually rewrite this as 2 equals to 2 times 9 minus x squared to the power of 1/4. Okay? And then use it here, so that would be 2 times, using the rule that we said, 1/4 times the derivative of 9 minus x squared, that would be negative 2x, times 9 minus x squared to the power of 1/4 minus 1. Okay? So 2 times 1/4. So now the combined like terms, you have 2 times 1/4 times negative 2. That would be negative 1. So negative 1x times 9 minus x squared to the power of 1/4 minus 3. That's negative 3/4. Or someone may decide to write it as negative x over 9 minus x squared to the power of 3/4. Are we all on the same page, guys? You guys agree with me? That's one approach, right? That's one approach. Or the other approach would have been using the chain rule. Using the chain rule. Let me finish this first, and I'm going to go back to question 7. Using the chain rule. The chain rule, so if I want to use the chain rule here, chain rule. We have y is equal to 2 times 9 minus x squared to the power of 1/4. So the inside function is g of x. That would be 9 minus x squared. So that means g prime now is going to be negative 2x. Here my outside function would be 2 times x to the power of 1/4. And then f prime now would be 2 times 1/4, that's 1/2, x to the power negative 3/4. And then we use it, so you know it's gonna be f g prime times f prime of g of x. So now we get g prime is gonna be negative 2x times f prime, that's 1/2, x, and replace x by g of x. G of x is 9 minus x squared. So 9 minus x squared to the power of negative 3/4. Simplify, same thing again, negative 2 times 1/2, that's negative 1, so negative x times 9 minus x squared to the power of negative 3/4. So you have two ways of doing this. So we have two ways of doing this. Do you guys agree with me? So if you feel comfortable using this, go for it. If you feel comfortable using this also, go for it. That's the beauty of math. We need to put a stop. We need to put an end to math anxiety. We need to put an end to math anxiety. Okay, so here then, this is going to be y prime, my bad. I mean to write dy over dx. So, which means that now dy over dx, this is dy over dx. So you guys see that we have the same question. Yes, Geo, like that's what I'm asking, guys. So some of you guys, listen to what I'm saying. I need you guys to be listening 100%. So I'm saying that now I'm working on having all the lives that we did so far, because I don't know how busy you guys are. And with the time difference, some of you guys may not catch the live at the right time. And I'm pretty sure that it's going to be stressful if you join and you don't know what's going on, right? Asking questions, what are we doing here? What is this chapter? Is this? What chapter is this? What lesson is this? What grade level is this? So in order to take care of all of that, all I'm saying is I can have all the lives that we did, all the full lives, TikTok lives that we did so far, and then you guys can have unlimited access to it. Unlimited access to it. That means you're busy, you see me, I'm live, but you're busy. That's okay, you don't have to stress. You can watch it another time. Or you're watching it and you gotta go, you can watch the rest another time. So how many, I need to know you guys, I need you guys to be honest. How many of you guys will be in favor of that? How many of you guys will be in favor of that? Put in the chat, please. How many of you guys will be in favor of that? Matter of fact, let me create a poll here, because I know some of you guys are busy. I know how this can get. We all know that. Right? So let's vote yes or no in favor of having a library where you can access all our TikTok lives. How many? How many would be in favor? Okay, so far I see one. I need everybody to vote. You gotta vote. How many would be in favor? How many would be in favor of having that? How many would be in favor? Okay, I see 3. How many of you would be in favor of having a library where you can access all our TikTok lives? How many? So far is 3. I need everybody to participate. Okay, so I want to make it easy on you, so you don't have to stress with the time zone and everything else. No more worry of that. But I need to know how many are ready to have that library built where you can access all our TikTok lives from the beginning till the end. no editing, no nothing. Just pure raw reactions, live teaching. How many? How many? How many? Good luck to Amio SAT. That's fine. You guys let me know. You guys let me know. Let me know. Let me know. How many would be interested? Will you be interested in having full access to our TikTok Lives Unlimited? Just take the derivative or hope for the best. Once you take the derivative, this guy is a joke. I like those jokes though. Just take the derivative and hope for the best. Shall we move on to the next one? Let's move on to the next one. So what's the derivative here? Y is equal to 1 over x minus 2. What is y? dy over dx. Someone is asking a great question. Do we have to use the quotient rule? Do we use the quotient rule here? What do you guys think? Should we even use the quotient rule here? What do you guys think? Should we use the quotient rule here? Okay. So guys, we're looking for derivative. You can actually use the quotient rule here, but you don't have to. Let's look at the normal way. Let's look at this, okay? Why don't we rewrite this? Why don't we rewrite this as y is equal to x minus 2 to the power of negative 1? Do you guys agree with me on this? Do you guys agree with me on this? Okay, so which means that now dy over dx, we're using the power rule or the chain rule. That will be -1 times x minus 2 to the power -1 minus 1. That will be negative x minus 2 to the power -2. Can also be written as -1 over x minus 2 to the power of 2. That's right, Abdullahi. Any question on that? Any question? You guys, we're doing derivatives. We're not doing integrals. We're doing derivatives. So when you say let u is equal to x minus 2, what does that mean? Are you trying to use u substitution here? We're doing derivatives, not integrals. If that was integral, then yeah, you can use u substitution. Okay, or you can use the quotient rule too. Right? So the quotient rule we have, you guys know already. Low d high minus high d low over okay. So then this becomes dy over dx now becomes derivative of 1 that's 0. So 0 times x minus 2 minus 1 times 1 over x minus 2 to the power of 2. That would be -1 over x minus 2 to the power of 2. You can do that too. Are we all on the same page, guys? Are we all on the same page, guys? Let's take this last question. So what are we gonna do here, guys? What are we gonna do? Can I write this as y is equal to 3x plus 5 to the power of -1/2? Can I do that? Can I do that? Can I do that and then use the chain rule? What do you guys think? Can I rewrite it as such and then use the chain rule? Okay. So now what does that become? So then dy over dx now. The inside function is 3x plus 5. The derivative of 3x plus 5, that would be 3 times the derivative of the outside function. That would be -1/2 times blank negative 3 halves. And blank here is going to be 3x plus 5. So that would be negative 3 halves x plus 5 times negative 3 halves. Do you guys agree with me on this? This is Calc 1. This is Calc 1. All right. Any question? This brings me to the end of the live. Anybody in the chat has a question? Okay, like I said, guys, I know how busy you can be, life can be. Okay, listen to me carefully. I know how busy life can be. And there are times that when I'm live, you're not even aware that I'm live. Or you are busy. Right? You guys agree with me? You are busy. I'm not saying that there is anything wrong with being busy, but there are times where you are busy and I'm going live. And you don't want to miss that. Or there are times where you join late or you join early and then you have to go. Anyway, the bottom point is most of us don't have time to sit the whole entire live. Right? Do you guys agree with me? Most of us don't have time to sit the whole entire live. So here is what I'm saying. Would you consider the option of having full unlimited access to our TikTok lives from the beginning to the end? The full live. I'm not talking about short clips like what we have on TikTok. Full entire lives. The full entire thing. You can replay whatever it is. Would you consider that? And it's not going to be calc. Like I said, it's going to be all the lives that we had. We had lives on limits. We had lives on derivatives. We had lives on integrals, double integrals. We had lives on algebra, pre-algebra, pre-calc, calc, you name it. Would you consider that? Let's just be honest. Where a safe space, where we can interact, we can all interact, we can ask questions. Would you consider that? Having access to the lives, having access to the worksheets. Would you consider that? You guys don't say anything. I need your feedback, guys. I need your feedback. I need your feedback. So I want you to benefit as much as you can, right? Because we're giving this for free. But I need you guys, I need your feedback and I need your support on this. I need your support on this. I need your support on this. So again, how many of you guys would be interested in the idea of having a library where you can have full access to our TikTok lives? Safe environment. You can ask questions. We can have challenge, whatever, right? Challenge questions. Interact. Build that community. right? Worksheets. You guys been asking me for worksheets. You can have worksheets with the solutions, practice. How many of you guys would be interested in this? Okay, so far I see two. So far I see two of you guys. So far I'm seeing two of you guys. Okay, I see three. Who else? It's 13 of us right now in the live. Okay, 4. Who else? Who else would be interested? Yes, we're gonna have, like I said, it's gonna be a space, safe space where you have access to all the TikTok lives, whether it's on Calc 2, it's on Calc 1. We're gonna build that community. Yeah, we do calculus too, but we don't lecture. We do it, you think different and we solve together. That's what SIGMATH does. I'm not here to lecture you guys. If it's lectures, I'm pretty sure we have tons of lectures. But making sure that we put an end to math anxiety. We have to stop math anxiety. You can walk the whole point. The goal is making sure that you walk into your math class with confidence. Make sure you DM me. Mazen, send me a DM. Okay? So I will keep you guys updated. Thank you for showing up. You showed up for yourself. Thank you for building the community. It's all of us in this together. Okay? So you're part of it. I want you to own it. You're part of the SIGMATH community. I want you to own it. Come participate. There is no wrong answer. We all here to learn. As a community, challenge each other, push each other, contribute to the discussion. That's what we do here. Whoever saw me lecturing on the live, whoever, have you ever seen me lecturing on those lives? Be honest. Who has ever seen me lecturing on those lives? No, we get right into the work. Make sure we understand. We want to put a stop to math anxiety. We want to put a stop to math anxiety. Okay? So I really appreciate you guys who showed up. Thank you for everything, supporting, either by tapping on the screen, being active in the chat, following. I really appreciate you guys. Until then, peace. You already know, we are out.